Most applications have a menu. Even if there are no menus on the secondary windows, there is usually a menu on the main window. A menu is simply a bar across the top of the window with a few pull-downs. You construct each piece of the menu separately and then hook them all together. This program is an example of one with a simple menu. You need to import the JMenu bar, which is the bar that holds the pull-downs, the JMenu class, which is the pull-down portion, and the JMenu item, which is a menu push button. You will need to implement the Action Listener interface so you can receive events from the mouse clicking on the menu. Oh, by the way, I've done something a little different in this example. You may remember that in previous examples I used an anonymous class to receive the event of the window closing. Here, the call to set default close operation does the same thing. When the window is closed, the application closes. Now, whenever I construct a menu, I do so in a separate method. That's because I have found that having all the menu code isolated in one place is very handy. It makes things easy to find when the need comes to make a change to the menu, and believe me that menus change a lot. This method returns the JMenuBar object, which is to be placed across the top of the window. The call to the JFrame method setJMenuBar installs the menu at the top of the JFrame. This is the method that builds the menu. It begins by constructing the menu bar itself. This is the first pull-down. By convention, the first pull-down is named File. Notice the call to set lightweight pop-up enable to false. If you don't do this, the pull-down menu will actually come up behind some of the components on your window and not be visible. The add method is called to insert this pull-down as the first member of the menu bar. The creation of the JMenu item is the creation of a menu button. This example uses only text, but you can use an icon just like you can with any button. This object is added to the button as its action listener, and the button is added to the menu. Two more buttons are constructed and added to the menu. They will appear in the order that they are added to the menu. In this example, a second pull-down is added to the menu bar. It will be positioned directly to the right of the one that's already there. Finally, a couple of buttons are added to the new pull-down. This is the method that's called with each menu button. This example simply prints out the text from the button. It responds only to the exit button by closing the application. Here's how it works. You can see the menu here exactly as it was defined. In the next lesson, I will show you how you can use components other than simple push buttons inside menus. After you work with menus for a bit, you may find that there are some other things you'd like to do with them. Well, you can. The swing menu system has a few fancy things you can add to your menus. For example, you can have checkboxes and radio buttons. Let me show you how radio buttons work. You will need to import a new kind of menu item, a radio button menu item. And you may want to declare your radio buttons so you can get to them later. After all, one of the purposes of a radio button is to click and stay clicked. And you may want to be able to read it. You build your menu in the normal way. Here a pull-down menu named Choose is added to the menu bar. In a group of radio buttons, when you select one, the others become unselected. It is the button group object that keeps that straight for you. The radio buttons are created and added to the menu in the normal way. Each radio button is also added to the button group. and each radio button adds this object as the action listener. In the action performed method, the radio buttons are responded to the same as regular buttons would be. Here's how it works. As you can see from the action and reaction, the menu vanishes each time you make a selection, but when you re-show the menu, it shows that the selection was actually made. One of the things that's done a lot is the grouping of menu items. That's done by entering separators. You do that by inserting one line of code. You can add a separator into the menu anywhere you want. Here's what it looks like. You can see how the separator sort of groups the menu items. Adding a submenu onto a menu is done the same way a pull-down menu is added to the menu bar. You build a menu object, in this example named color, and set lightweight to false, the same as you would with any pull-down menu. Then you add it to an existing pull-down, the same as you would add any menu item. Then you can add button menu items or any menu items you wish. You could even continue with more submenus. Here's how it looks. When you pull down the parent menu, the submenu is marked so you can tell it's something besides a regular menu button. The submenu comes up in the normal way. You may want to be able to temporarily disable a menu button. Here's how you do that. You build your menu in the normal fashion. No special items are needed on import. However, you will need to save a reference to the menu item you wish to disable. This is so you can get to it when you want to change its status. Everything can be done in the normal way. By default, all menu items are enabled. To disable a menu item, you call setEnabled and set it to false. To enable the menu item again, you call setEnabled and set it to true. Here's what it looks like. You can see that the first menu item here is enabled, but select disabled and you can disable it, and it will appear grayed out and it simply doesn't work. Enabling it again causes it to appear normally and to work. Complex menu arrangements can have a dramatic effect on the look and feel of your application. In the next lesson, I'm going to show you more information on the variety of look and feel in Java applications. Your Java program is sort of like a chameleon. It will change its look and feel to match the style of other programs on your system. The look is the appearance of the components, and the feel refers to the way they behave. The Swing Manager will automatically select the look and feel for you, so there's nothing you need to do. Your application will automatically morph to the system on which it's running. For the Solaris or Linux system with GTK 2.2 or later installed, Java has a look and feel interface named GTK+. If GTK is not installed, Java has a motif look and feel that it uses. IBM's version of Unix is called AIX, and IBM has its own Java look and feel. Also, HP's Unix, HPUX, has its own Java look and feel. Java has a different look and feel interface for the different versions of Windows, and Apple Macintosh has its own look and feel for Java. There is one other look and feel. It's the cross-platform look and feel, also known as the Java look and feel. You will also see it referred to as the Metal look and feel. It's commonly used as the default, and it is the one that you've been seeing in the examples for this course. You can invoke a different look and feel if you wish, but you need to choose from among the ones that are installed on your system, and you need to do it at the very beginning of your program, before anything is displayed. I have an example that lets you choose from the installed look and feels. You will need to import the UI Manager class. The User Interface Manager. All the work is done in main. Now every system is a little different, so you will need to get a list of the look and feel classes that are installed and ready to be used. You can pretty well count on there being more than just the default one. This loop prints out the list of class names. It's usually a short list, 3 or 4 names. The names are the fully qualified class path names. The getIndex method is a local method written for this example. All it does is read a single-digit integer from the keyboard. The index it reads is used to choose one of the installed look and feel classes. It is the name of the chosen class that is used to specify the look and feel. This method can throw any one of several different types of exceptions, but if it doesn't, the new look and feel will have been applied. Here's how it looks. As you can see, there are 4 look and feel options to choose from. The first one is the default. If you make no change, it will be the one that's applied. This interface makes the application look like a standard Windows application. It looks like something written in C++ or BASIC. Using another look and feel makes it almost seem like a different program is running. The coloring, font, button, declarations, everything looks different and acts a little different. If you wanted, you could write your program to try to find different looks and feels and use one only if it's present. Next is a lesson about how you can use the toolbars for another approach to the user interface. You can add a toolbar to any window. It's just a row of buttons inside a toolbar manager. Actually, you can include any kind of component you want in a toolbar, but people have come to expect small buttons with images on them. Toolbars are normally included along with menus. Toolbars come in handy for people who use the application a lot and don't need prompting for the actions they want to take. Here's how you build a toolbar. The JToolbar class is the toolbar manager, so you'll need to import that. The toolbar in this example is made from buttons with pictures on them, so it needs the JButton class and the image icon class. The border layout manager plays an important role in managing toolbars. You construct your window from components as usual and place them in the center position of the border layout, and the edge positions are all used by the toolbar. You can do this with any kind of window. This example uses a J-frame. And you'll need to implement the Action Listener interface to listen to the buttons. The Build Frame method constructs the layout for this example. You can use anything you want in the center. This example uses a text area inside a scroll pane just to display the results of the toolbar selections. A toolbar is constructed and a number of buttons are added to it. The buttons are all scaled to the same size, so the toolbar is uniform. I'll show you that here in just a minute. The toolbar is added to the border layout at one of the edges. Any of the 4 positions will work. This example uses north, the top of the window. The Make Tool Button method is used to build the buttons. 2 parameters are required to define each button. One is the name of the file containing the image, and the other is the command string that will be assigned to the button. None of the buttons display text, so it's necessary to provide command strings so the program can recognize which button has been selected. Each image is scaled to the same size, so the buttons will all be the same size on the toolbar. The action command is assigned to the button, and the button is given this object to be its action listener. The action command method retrieves the command string from the button and adds it to the new line in the text area. The text area is then notified to repaint itself. Here's how it works. You can see the toolbar across the top of the window with the 4 buttons in it. Each time a button is selected, the command string for that button is printed in the window. The toolbar can be dragged from one position in the border layout to another, and it still works the same as before. It can be placed in any of the 4 sides. It can even be parked elsewhere in the screen. The buttons still work normally. In the next lesson, I will show you how to combine a menu and a toolbar in the same application and how to add tool tips for both of them. A program that has a toolbar normally also has a menu that contains this same set of options. Some people like to use toolbars and others like to use menus, so it's a good idea to provide both. It's easy to do. Let me show you how. This is the same program that was used in the lesson earlier explaining how to build toolbars, but it has had a menu added to it. The options on the menu are the same as the ones on the toolbar. To combine a menu and a toolbar, you need to import everything for both, as in the previous examples. You will need to implement the Action Listener interface. This same Action Listener will receive events from the toolbar and from the menu. The menu bar and the toolbar are built separately, but in the same ways that they were built individually in the previous examples. The only thing new here is the fact that they are both included in the same window. The strings assigned to the toolbar buttons are important. They should be the same as the ones on the menu. At least it makes programming a lot easier if they are the same. The menu that's built for this example has one menu item button for each toolbar button. And the menu buttons are given similar names, but they're not exactly the same names as the buttons for the toolbar. The call to set action command for the menu item does the same thing it does for the toolbar. This is the string that will be reported to the action performed method. Here at the bottom of the program is the method that's called each time the menu item or a toolbar button is selected. This example copies the action command to the text area in the window. If you wanted to, you could call a method named getSource in the action event and determine which button was pressed, toolbar or menu, but it usually doesn't matter. All you need is the command string. You don't really care which button the user selected with the mouse. All you really want to know is the name of the command. You can see where you could have other buttons in the window issue the same exact commands. It's not unusual to have multiple ways for a user to do the same things. Here you have it. Different buttons, same results. In the next lesson, I'm going to show you how to add tool tips to let your interface explain itself. Tool tips, those little text pop-ups that appear when you hold the mouse pointer over a component. They usually contain text that answers the question, "What's this?" You can add a tool tip to every component displayed by your application. This is almost the same program as the one from the previous lesson on toolbars. This time a tool tip has been added to each toolbar button and to the text area in the center. With any class that has a J component as a superclass, you can use this same method call to insert text for a tooltip. A tooltip has been added to the text area in the center of the window with this call to set tooltip text. A new and third parameter has been added to the makeToolButton method. It is this string that is to be the text of the tooltip for the buttons. One line has been added to the method that makes toolbar buttons. The call to set tooltip text using the string from the new parameter adds the text to each button the method constructs. Nothing else has changed from the previous version. Here's how it works. If you let the mouse pointer rest on one of the toolbar buttons, a tooltip appears. Once the first tooltip has appeared, you don't have to wait for the others. They sort of pop up automatically. The tooltips continue to work regardless of the position of the toolbar. Waiting for a bit or moving the mouse out of the toolbar causes the tooltip to vanish. If you remember, this example also defined a tooltip for the text area in the center. Okay, that's all we'll be doing with the user interface for a while. Later in the course, we will be looking into splash screens and making sounds, but in the next few lessons coming up, we're going to talk about generics, one of the strange departures made by the newer versions of Java.